Hello everyone and welcome. Today we're diving into a really fundamental topic in chemistry, atomic structures. Trust me, by the end of this explainer, all your doubts are going to be crystal clear, especially when it comes to your exams. So let's get started.
Have you ever wondered what the real difference is between something like carbon-12 and carbon-14, or, how totally different elements, say potassium and calcium, could possibly have anything in common? These are super common questions in exams, and today we are going to answer all of them.
All right, first up, let's tackle three core concepts that, let's be honest, can cause a lot of confusion. Isotopes, isobars, and isotones. Let's break them down one by one.
So, first on our list, isotopes. Put simply, these are atoms of the same element. They have the same number of protons, but a different number of neutrons. And here's a super simple way to remember that. Notice how isotopes has a P in it? Well, that P is for protons, so isotopes means the same number of protons.
Let's look at a couple of classic examples. Take carbon. Carbon-12, carbon-13, and carbon-14, they all have exactly 6 protons. The only thing that changes is the number of neutrons. It's the same story with hydrogen, which has 3 isotopes, protium, deuterium, and tritium. Every single one has 1 proton, but they have 0, 1, or 2 neutrons. So remember, same element, same protons, just different neutrons.
Next up, we have isobars. Now, these are atoms of different elements, but they have the same mass number. And remember, the mass number is just the total number of protons plus neutrons. Their atomic numbers, though, are different. Here's a great little trick to remember this one. The word bar sounds a bit like the Hindi word bar, which means weight or mass. So isobars means same mass number. See? Easy. And finally, we have isotones. These are also atoms of different elements, and their special feature? They have the exact same number of neutrons. Everything else, the number of protons and the mass numbers, are both different. And yeah, there's a memory trick here too. Isotones has an N in it, which stands for, you guessed it, neutrons. So isotones means the same number of neutrons.
Let's check out an example, potassium-39 and calcium-40. Okay, for potassium, we take the mass number 39 and subtract the atomic number 19, and that gives us 20 neutrons. Now for calcium, we take its mass number 40 and subtract its atomic number 20, which also gives us 20 neutrons. See, both have 20 neutrons, which is why they are isotones.
Okay, this table right here is your ultimate revision guide. I seriously suggest you take a screenshot or jot this down. Isotopes, same protons. Isobars, same mass number, or bar, and isotones, same neutrons. Perfectly clear?
All right, on to section 2. We've talked about the nucleus, so now let's see where the electrons hang out. Welcome to Electron Shells, the atom's address. So it's a simple question. Where do these electrons actually live? If you imagine an atom is like a huge building, what's the electron's address inside that building? Let's find out.
Electrons live in what we call electron shells. These are basically specific energy levels, or orbits, that surround the nucleus. So just like a building has different floors, an atom has different shells. And the shell that's closest to the nucleus has the lowest energy.
These shells have names, K, L, M, N, and so on. We also represent them with numbers, like n equals 1, 2, 3, 4. The one on the very inside is the K shell, which has the lowest energy level. After that comes L, then M, then N. And electrons always start filling up from the lowest energy shell first, which means they start at the K shell.
Now, pay close attention to this formula, 2n squared. From an exam point of view, this formula is extremely important. It tells us the maximum number of electrons that can fit into any given shell. For example, for the K shell, where n equals 1, it's 2 times 1 squared, which is 2 electrons. For the L shell, where n is 2, it's 2 times 2 squared, which is 8 electrons. Simple, right?
Okay, let's get into a little more detail now. Even inside the shells, there are subshells. So if the shells are the floors of our building analogy, then subshells are like the different apartments on each floor. Let's take a deeper look.
So, what exactly is a subshell? In simple terms, it's an energy sublevel within a shell where you can find electrons. We label these subshells with letters S, P, D, and F. Just like the energy of shells increases as you go from K to N, the energy of subshells within a single shell also increases in a specific order. And that order is S, then P, then D, and finally F. This means the S subshell has the lowest energy and the F subshell has the highest.
This slide gives you a perfect summary of the subshells. The S subshell is spherical, has one orbital, and can hold a maximum of 2 electrons. The P subshell is shaped like a dumbbell, has 3 orbitals, and can hold up to 6 electrons, and so on for D and F. Make sure you memorize this table for your exams. It's really important.
All right, we've covered all the core concepts. Now let's do a quick, high-energy revision session. We're going to focus on the most important takeaways that are going to help you score full marks on your exams.
Okay, let's lock in these final takeaways. Isotopes, same protons. Isobars, same mass number, or bar, and isotones, same neutrons. And remember, shells are the main energy levels and subshells are the subdivisions inside them.
And here's a final thought for you. Now that you know how electrons are arranged in these shells, how do you think that arrangement decides which elements react with each other and which ones don't? Keep thinking. अगर आपको ये वीडियो हेल्पफुल लगी हो तो लाइक, शेयर और सब्सक्राइब करना ना भूलें और कमेंट करके बताएं अगर आप किसी स्पेसिफिक टॉपिक पे वीडियो चाहते हैं।